Okay, so trigonometry is one of the most useful branches of mathematics, and in this section we're just going to learn some applications of it. And we'll start with a simple example. We're going to find the altitude of this triangle and its isosceles because the two base angles are the same. So we want to find the altitude of this triangle. And since it's isosceles, then that altitude bisects the base. And we're given that each theta is 52 and b is 4. So that means that if I pull out this half triangle that I just created, that angle is 52 degrees. That's 2. And I'm looking for h. So if we're down at this angle right here, the two pieces of the triangle that we're working with are the opposite side and the adjacent side. So that means that the tangent is the function we want to use. So the tangent of 52 degrees is going to equal the opposite side over the adjacent. So 2 times the tangent of 52 will equal that altitude. And let's get our calculator up. And you want to make sure you're in degree mode, and we are. And so I just hit 2 tan 52, and we get that the altitude is about 2.6. Okay, inches. I'll make that a little bigger so you can see it. Okay, in this problem we have a child 4 feet tall, and she's flying a kite attached to a 75-foot line. So here's the ground, and here's the 4-foot tall child, and we've got a kite line that's 75 feet, and it's attached to a kite. And we'd like to know if the angle of elevation of the kite is 60 degrees, how far above the ground is the kite? So we'll call this h, and remember that this little bit right here is 4. So we're going to solve for h, and then we'll add 4 to our final answer. Okay? So once again we're going to ask ourselves, okay, what pieces of this triangle am I looking at if I'm at this angle? And we have the opposite side and the hypotenuse, so that should mean we're going to use sine. So we set up our equation. The sine of 60 degrees is the opposite over the hypotenuse. So 75 times the sine of 60 is h. Now we're ready for our calculator. And I punch that in, 75 sine 60, and we get 65. Don't forget to add the 4 feet of the kite flyer's height, and that's going to be 69 basically. Alright, on this problem we have a cell phone tower 150 feet tall, and it's on top of a mountain that's 1,200 feet above sea level. So let's draw a diagram. Okay, here is sea level, and the top of the mountain is 1,200 feet above sea level. So here's my mountain. So that's 1,200. And what is the angle of depression from the top of the tower to a cell phone user who is 5 horizontal miles away and 400 feet above sea level? Okay, so let me get some room here for the cell phone tower. So here's the cell phone tower, and that is an extra 150 feet. And then 400 feet above sea level is the observer. So this is 400 feet. And this person here is looking at the top of the cell phone tower, and he is 5 miles away. Okay, so I think I have all my measurements. And the question is, what is the angle of depression? Now, this is not the angle of depression. You always measure angles of depression or elevation from a horizontal. So that's our angle of depression. And because it's an alternate interior angle with this one, that's the same thing. Okay? So, how much is that distance right there? Well, from here to here is 1200 minus 400, so that's 800, plus 150 means that that's 950 feet. Okay? So I know the opposite side. I also know the adjacent side, but it's in miles. And so remember that 5 miles we have to multiply by 5,280 feet per mile to get how many feet that is, because we need to have everything with the same units. So 5 times 5280 is 26,400. Okay. So I think we know everything we need to finish this problem. We know the opposite side, we know the adjacent side, so we're going to say that the tangent of theta is the opposite over the adjacent. Now, I am looking for an angle, so that means that I have to use inverse or arctan to get the angle. So, I'm going to bring up my calculator again, and this time I'm going to go second tangent 950 divided by 26,400. And we get that that angle of depression is about 2.1 degrees. Our next problem deals with bearings. And we have a surveyor that would like to measure the distance across the swamp without walking across it. So what he does is he's going to take a bearing from A to a point across the swamp B, and we'll draw our own little picture out here. There's A, B, C, and he finds that the bearing is north 32 degrees west. Bearings are always measured from the north-south axis. So if that's north, then 32 degrees west is right there. This is a right angle, so that makes this 58 degrees. Okay, then the surveyor walks 50 meters from A to the point C, and at point C the bearing is 68 degrees west. So if I connect B to C and draw another north-south axis, then this angle here is 68 degrees. Now if I extend this out, then AC is a transversal of these two parallel lines, which means that this angle 58 corresponds to that angle 58. And that's helpful because now 58 plus 68 plus this angle have to add up to 180. So let's get our calculator, and we're going to go 180 minus 68 minus 58, and that angle is 54. Okay, and this distance AC is 50 meters. Now we know enough to get x. I know this angle, I'm looking for the opposite side, I know the adjacent side. So the tangent of 54 degrees is the opposite over the adjacent. So 50 tangent 54 will give us x. Get our calculator up again. And I'll just put in 50 tangent 54, and we get about 69 meters. Okay, so the bearing from A to C, that's part A. That's this right here is 58 northeast. So the answer to part A is north 58 degrees east. In part B, the distance from A to B is 69 meters. All right, another bearing question. A ship is 45 miles east and 30 miles south of port. So if we make this point our port, then I'm going to go 45 miles east and 30 miles south. And here's our boat. If the captain wants to sail directly to port, so if we want to go straight to port, what bearing should be taken? In other words, what's theta going to be? Well, once again, opposite and adjacent, so we're going to use tangent. The tangent of theta is 45 over 30. I'm looking for an angle, so I'm going to do the arctan of 45 thirtieths. You could reduce that if you wanted to 3/2. And that's a calculator problem. Second tangent 3/2. And the answer is 56.3. Now when you're talking about bearing, remember, you have to tell what direction that angle's going in. And so it's north and then west. So the answer is 56.31 degrees northwest. Last one. A point on the end of a tuning fork moves in simple harmonic motion described by this function. Find omega. That's what that funny looking W is. Find omega given that the tuning fork for middle C has a frequency of 264 vibrations per second. Wow, that sounds complicated. But fortunately, it's not. So remember that the period of a sine function is 2 pi divided by that number in front of your variable, t. The frequency is the reciprocal of the period. So guess what? I'm going to say that 264 is the reciprocal of 2 pi over omega, which is omega over 2 pi. So 264 times 2 pi will give me omega. And let's get our calculator up. And I just go 264 times 2, which is 528 pi. Or if I wanted to do it in decimal form, about 1,658.8. And that does not have any units. All right, hope you enjoyed all those applications of trigonometry.